lesson 4 is reasoning with polygons. So a polygon is a closed plane figure that has 3 or more sides. So a triangle, quadrilateral, squares, rectangles, pentagons, hexagons, those are all types of polygons. When all of the sides in the polygon are equal to each other, it is a regular polygon. When they are not, it's called an irregular polygon. Some of the polygons have special names, such as pentagons, hexagons. Once they reach a certain, actually, we probably could find the proper name for all polygons. We just don't use multi-sided polygons all the time. So what I had you work on was this chart with the regular polygons. If I drew a polygon inside of a circle and joined the vertex to the center of the circle, I get these isosceles triangles. And they're isosceles because these lengths here correspond to the radius of the circle, so they're all the same. So if 2 sides of a triangle are the same length, I get the isosceles triangle. So if I skip down to the pentagon, we said that a pentagon has 5 sides. So the measure of the central angle would be 360 divided by 5, which is what?
72.
So then the measure of the base angle of the isosceles triangle, what that means is if this angle here is 72 degrees, what are these 2 angles? And because they're isosceles, the 2 angles have to be the same. So to find out what those 2 angles are, I can take that 72 away from the 180 and then divide that in half. And what do I get when I do that? 54 degrees. And then the next part is the measure of the interior angle of the polygon. And we get that by doubling the base angle. So when I double the base angle, I get 108 degrees. So what that is this. That's finding this angle right here. That's the 108. Because if this is 54 degrees and these triangles are all the same, this will be 54 degrees. And then the last thing that you're asked to find is what is the sum of the angles, or the interior angles. So there's 5 angles, each of which measure 108 degrees, which altogether would give me 540 degrees. Okay? So a nonagon has 9 sides. So the measure of the central angle would be 360 divided by 9, which is equal to how much? 40 degrees. The base angle is I subtract that 40 from 180 and divide the answer in 2, which gives me 70 degrees. So then the measure of the interior angle would be to double that base angle, which gives me. And then to find out the sum of the insides of, or the inside of a nonagon, 9 sides, 140 degrees for each, is how much? The 1,260. In a dodecagon, we have a 12-sided figure. So what is the measure of the central angle? 30 degrees. 360 divided by 12. And what is the measure of the base angle? Be 180 minus 30, which is 150, divided by 2. And then the interior angle would be double the 75, which is 150. And then the sum of the interior angles would be 150 times 12, which is 1800. So the last line is an n-sided polygon. So kind of in a sense developing formulas for how could I find this no matter what, how many numbers of sides I had. So this becomes n. So now we're almost moving to deductive reasoning. So the measure of the central angle, in all of these, I found the measure of the central angle by going 360 divided by n. So then the measure of the base angle, I took 180 degrees, subtracted this value here, which now I can write as my 360 over n, and then I divided that by 2. So what's 180 divided by 2?
90.
So I can simplify this to get 90 degrees, and then 360 divided by 2 is 180 degrees over n. And that'll give me the base angle of the isosceles triangle. Measure of the interior angle, what did I do in that step? I multiplied this by 2. So if I take this 90 degrees minus 180 over n, and I multiply it by 2, I'll square it. It's what I ended up with before. I divided by 2. So 90 times 2 is 180. 180 times 2 is 360. And then in the last step, it says the sum of the measures of the interior. I figured that out by taking this number of sides and multiplying it by the number or the measure of the interior angle. So if I took n and I multiplied it by 180 minus 360 over n, I get 180 times n, and these two n's cancel each other out. So I get 180 times n minus 360. And from here, 180 and 360 have a common factor. I can divide them both by 180. Divide this term by 180 and I'm left with n. 360 divided by 180 leaves me with 2. So I get 180 times n minus 2. On the next page, we looked at irregular polygons. And this time, when we were looking at irregular polygons, we split the polygon into non-overlapping triangles. So if I have a 4-sided figure, I can get 2 triangles. A 5-sided figure gave me 3 triangles. And then you were asked to choose a vertex and join that vertex to the other vertices to construct non-overlapping triangles. So if I do that, if this was the vertex I chose, there's 1, 2, 3, 4, 5, 6. There are 6 triangles that I created here. If I do the same thing to this shape, 1, 2, 3, 4, 5, 6, 7, and then the remaining one would be 8. So this one gave me 8 triangles. 1, 2, 3, 4, 5, 6 triangles. And then we have another chart somewhat similar to the well, not similar, a little bit different from the previous page. So in a triangle, 3 sides, there's only 1 triangle. The sum of every triangle is 180 degrees. If I have one triangle, it means all of it adds up to 180 degrees. If I have a quadrilateral, I can make two triangles. That was this shape right here. If each triangle is 180 degrees, together I'm going to get 360 degrees. In my pentagon, I think that's the next one, pentagon has 5 sides. How many overlapping triangles can you make? Non-overlapping triangles. This is my pentagon. How many triangles did I create? 3. So 3 non-overlapping triangles. So the sum of the measures of the interior angles would be 180 times 3, which is 540 degrees. Then if I look at an octagon, how many sides in an octagon? 8. This is an octagon. 1, 2, 3, 4, 5, 6, 7, 8. How many triangles did I create? 6. So 6 triangles at 180 degrees each gives me how many degrees in total? Okay. A decagon. How many sides does a decagon have? 10. And this was the decagon right here. How many triangles did I create? 8. So 180 times 8 triangles is how much? What'd you get, Talia? 1,440. Suppose we had a 100-sided polygon. How many sides does it have? 100. If I was to try to make non-overlapping triangles, how many triangles do you think I'd get?
98.
So then how would I find the sum of the measures of the interior angles?
It would be 180 times 98.
And what is 180 times 98? Okay. So then we have our n-sided polygon. It has n sides. How many triangles can I create from my n-sided polygon? What's the relationship between these 2 rows each time? Or 2 columns? It's 2 less. So if I take n, I take 2 less than n. And then how do I use the sum of, or sorry, how do I use the number of triangles to calculate the sum of the interior measures? What did I multiply these numbers by?
180.
So I would take 180 and multiply it by n minus 2. Have we seen this formula before? It was right there. So it doesn't matter if I have a regular or an irregular polygon, the sum of the measures of the interior angles is calculated the same way. 180 times n minus 2. That's this property. The sum of the interior angles of a polygon is 180 times n minus 2. We can extend this property if I have a regular polygon to find the measure of each interior angle by taking this and dividing it by the number of sides. So if I find the sum of the angles in a 10-sided figure, each angle I would then divide that sum by 10, and that would give me the measurement of each angle. And then this part here simplifies it. So it just cleans up this formula. I can extend that property to the exterior angle. So when I draw